Good afternoon. I decided to go ahead and tape up the rest of Lecture 8 so that we can be on time with our syllabus and so that you can have a little bit more time to go through this material. Some of it is new, and so just want to make sure that we can get it down for you. We were talking about slope and we're talking about linear equations. We've gotten all the way through this part. I'm going to review a few of those problems and then we're going to be talking about functions. Okay, we begin with the idea of slope, and this is the first page of the lecture. You've got it in your notes, and we know what slope is. We know that it's the change in y over the change in x. So when you think of slope, you want to think of this ratio idea, the idea of rise over run, and it's the difference in the y values over the difference in the x values. And we have seen already that you need to be very consistent with the way that you subtract and choose which is y2 and make sure that your x2 corresponds. Okay, so we've done that already. And we were up to the point of trying to write equations of lines. And we started with a vertical line. If we look at the equation x equals 2, by our definition of coordinates, x is the distance from the y-axis. So we're saying find all points that are 2 units from the y-axis, and if you look at those points, they all lie on a vertical line. So a vertical line is always going to have the equation x equals a constant. It will go through the intercept a0, whatever that a value is, and when we think of slope, slope is change in y over change in x. Well, what's the change in x? If I take any 2 points on this line, they have the same x coordinate. So it's going to be the change in y over 0. There is no change in x, and so the slope is undefined. So vertical lines have no slope, because if we think of that ratio of change in y over change in x, there is no change in x. On the other hand, a horizontal line represents all points that are a certain unit or a certain distance from the x-axis. In this case, y equals 3 is all points above 3 units above the x-axis. And we can see that its equation is y equals 3 and that the line is horizontal. And so a horizontal line has the equation y equals a constant. The y-intercept is the point 0b, and the slope this time is change in y over change in x. Well, x can change, but what about the y values? They're all the same. And so the distance, the change in y, is always 0. So a horizontal line has slope of 0. A vertical line has no slope. Okay, so then we start by considering a line that is not horizontal or vertical. And so we make sure that it's non-vertical, and the reason it has to make sure it's non-vertical is because it has a slope. So we have a line L, and we know 2 things about the line. We know its slope, and we know one specific point on the line. Okay? And then we just choose any other point, x, y, that's also on the line. And what do we know? We know that the slope between those 2 points is the change in y over change in x. In this case, it's y minus y1 over x minus x1. And since the line is non-vertical, we know there's going to be a non-zero change in x. And so that's perfectly valid. And in fact, what we can do is multiply both sides of this equation by x minus x1. Okay, so we're taking this equation, m equals this. And we get the following. Okay? And then if we rewrite that, we get what we call the point slope form of the equation of a line. And you're probably familiar with this from previous courses. So if you know the slope and you know a point on the line, we can write its equation. X and y are our variables. X1 and y1 are the coordinates of the specific points. So let's look at an example. We want to write the equation of the line through these 2 points. Now to use the point slope formula, we have to find the slope, okay? And so how do we do that? Well, we have a formula. We just use our formula, change in y over change in x. And I can subtract in either order. I guess I'll do 1 minus a negative 2 for the change in y. And that forces me to use negative 4 minus 3 for the change in x. Okay? And that gives me 3 over negative 7, or negative 3 over 7. It'll be easier to use the formula if the minus is in the numerator. Okay, any question on that? All right, then we find the equation using the point slope formula. And we can choose either of these points to use. I'm going to use the point x1, y1 as our point negative 4, 1. Okay, and then I just use my formula. Remember, y is the variable, minus y1, which is 1, equals our slope, times x minus x1, which is negative 4. Okay, using that first point. And so I have y minus 1 equals negative 3/7 times, squeeze it in here, x plus 4. Now that technically is the equation of the line. Okay, I've done what I achieved, what I wanted to achieve. I've found an equation relating those variables x and y. But we don't want to leave the line in that form. So let's see if we can make it look a little bit nicer. The first thing we can do is multiply both sides by 7 to clear our fractions. And remember that x plus 4 should be in the numerator. Okay, and so I get 7y minus 7. Here the 7's cancel, and I get negative 3 times x plus 4. So moving up here, 7y minus 7 equals negative 3x minus 12. And so if I bring everything over to one side, I get 3x plus 7y plus 5 equals 0. And that's the equation of that line in general form. Okay, now for practice, why don't you try using point slope formula with the second point, which was 3, negative 2. And slope is still negative 3/7. Use the same formula and see that you get exactly the same line. It doesn't matter which of the points you choose on the line. Okay? All right. Now the other form of a line, which is really more useful to us because it gives us more information, is the slope-intercept form of the equation of a line, sometimes called standard form. If you remember, standard form of a circle is the form where we can find the center and radius. X minus h squared plus y minus k squared equals r squared. Standard form is the form that's most useful. And for a line, the standard form is the slope-intercept form. And to find that, we just use the point slope formula for our given line. So this is my x1 and my y1. The slope is m. So what do I have? Y minus y1, which is b, is slope times x minus x1, which is 0. That's just using the point slope formula. And then I get y minus b equals just m times x. And I get the point slope formula, y equals mx plus b. That's the form that corresponds to the standard form, y equals mx plus b. Okay? So, write the equation of the line through negative 3, 1 with y-intercept 0, 5. Okay? I should mention that your textbook uses y-intercept as just being 5 as well, but we know that that corresponds to the point 0, 5. So either of these forms, and in WebAssign they will tell you which one they're looking for. If it's an ordered pair, they'll indicate that. Okay, so we have a line and we have 2 points. So we can find the slope. And once again, it's change in y over change in x, which is 1. This way, I'll make things positive. Let's subtract this way. 5 minus 1 for the y values. Then it's going to be 0 minus a negative 3. So that's 4 over 3. Okay, everyone with me? 5 minus 1, so it's got to be 0 minus a negative 3. Okay, and we also know the y-intercept, b, is equal to 5. So we write the equation. Y equals mx plus b. Y equals 4/3 x plus our intercept 5. Okay? So as long as we know the slope and the intercept, we can write our line in slope-intercept form. Okay. Now we can also write the equation of a line which is not given to us in slope-intercept form. Okay? And so the first thing I want to do here is get this equation in slope-intercept form, and remember that is y equals mx plus b. And I like that because I know the slope and I know the y-intercept. So let's do it by solving for y. So minus 3y equals negative 2x plus 6. Okay, taking this line, solving for y. Okay, and divide by negative 3. I'll do it in 2 steps. And y equals splitting that fraction up, which I can do. And it looks like y equals 2/3 x minus 2. That is the slope-intercept form of that line. Okay, so what do I know? I know that m equals 2/3, and I know that the y-intercept is negative 2, which corresponds to the point 0, negative 2. Okay, so how do I graph it? Well, I know a point. I know this line goes through the point 0, negative 2. Okay, and I also know the slope m, which is change in y over change in x, is equal to 2 over 3. So what does that mean? That means when y increases by, well, maybe it's easier to start with x. When x increases by 3 units, y will increase by 2 units. Okay? Now I can also go the other way. If x decreases, notice it's negative 2 over negative 3. So if x decreases by 3 units, y will decrease by 2 units. And I get this point. And what I observe, all of these points lie on the same line. And you can confirm that this point 3, 0 is in fact a point on our original line. If x is 3 and y is 0, we do get a true statement. So that's my line. Okay, you probably remember this from previous courses. suppose we have two non-vertical lines and they have slopes m1 and m2. Two lines are parallel if and only if, what's true? The slopes are the same. And that's easy to see just by a picture. If lines are parallel, they're certainly going to have the same slope. And two lines are perpendicular if and only if the product of their slopes is -1, or m2 equals -1 over m1. In other words, the slopes are what we call negative reciprocals. And that comes from the Pythagorean theorem. There's actually a problem in your homework where you can look at that and see how that works. Okay, let's do an example. All right, let's find the general form of the equation of the line passing through this point and parallel to a line and perpendicular to the same line. Okay, so I know a point on my line, and let's call this line L. And this line I'm going to call L1. Okay, so if I want to write the equation of line L, I need to know two things. I need to know the slope and I need to know a point. Now I know a point, but how do I find the slope? So that's the first thing I have to do. And I don't know anything about the slope of line L, but I do know that line L is parallel to line L1. So what does that tell me? L and L1 have the same slope. Okay, the line I'm looking for and the line I'm given have the same slope. So I find the slope of line L1. And we've already seen how to do that. We solve for y. Okay, so 2x minus 4y minus 3 equals 0. That means minus 4y equals negative 2x plus 3. When I bring that over, negative 2x plus 3, divide by negative 4. And so it looks like y equals negative 2x over negative 4 plus 3 over negative 4. So that's 1/2 x minus 3/4. If I can squeeze that in there. So what's the slope of L1? It's 1/2 because I've put it the line in slope-intercept form. So the slope of L which is the line that is parallel to this line, is also 1/2. Does that make sense? I know the slope of the given line, L1, and so that is exactly the same as the slope of line L. So I can write its equation. Okay, now I'm writing the equation of line L. I know that the slope is 1/2, and I have a point. So I use the point slope formula. Y minus a negative 3 equals the slope, which is 1/2, times x minus 1. All right, so again, this line L, I know that m is 1/2, and I know the point is 1, negative 3, and that's the equation. So I can write that as y plus 3, and I'll multiply through both sides by 2 at the same time. So it looks like 2 times y plus 3 equals x minus 1. 2y plus 3 equals x minus 1. And to keep x positive in general form, we get that x minus 2y minus 4 is equal to 0. Okay? Now, for part 2, we're looking for another line, L. Let's call this line L star. L star is perpendicular to our original line L1, and it still goes through the point 1, negative 3. Okay, so what do I need to find? I need to find the slope of L star. Okay, but L star is perpendicular to L1. Remember, L1 was the line up here. It's the same line. They're perpendicular. And this symbol, by the way, means it's an abbreviation for perpendicular. Okay, so what does that mean? So slope of L star is the negative reciprocal of the slope of L1. And we already saw that the slope of L1 was 1/2. We've already done the work previously. So the slope of L star then, it's the negative reciprocal. So it's minus 1 over 1/2. And that's minus 1 divided by 1/2, which is negative 2. Okay, does that make sense? Okay, it's the negative reciprocal. We knew the slope of L1, and so the slope of our perpendicular line is negative 2. So the equation of L star, y minus, now remember it goes through the point 1, negative 3. So y minus a negative 3 is equal to negative 2 times x minus 1, the x coordinate of our point. So y plus 3 equals negative 2x plus 2. And if I put that in general form, let's bring the x over to the other sides to keep it positive. Plus y plus 1 equals 0. Okay, and you can confirm that this line has slope negative 2 and that it contains the point 1, negative 3. In fact, we can eyeball that. If x is 1, 2 plus 1 is 3, and if y is negative 3, you do get 0. Okay, thank you.